Namaste, welcome back to the Pragna channel, and you are watching AWS Cloud Quest series, and we are in season 2, and so far in season 2 we have finished total 7 episodes, and each episode we have done a specific project which is nothing but a practical lab, right? So in today's episode we are going to do another project which is about data ingestion methods. So what are we going to do in this episode? We will help the package delivery company speed up data ingestion and transformation. Okay, and for people who are watching this for the first time, in season 1 we played this game. This is Cloud Quest is a video game where you do different AWS projects, which is nothing but practical labs, right? In season 1 we played this game as a cloud practitioner and implemented projects as a cloud practitioner. In season 2 we are playing it as a solutions architect, and we are doing projects a solutions architect would do in real life. With that being said, let's start our project number 8. So let's go. I don't know where they are, so instead I will go to my mobile app as usual, and then I will go to data ingestion methods, route and go. So he will automatically take me to whichever person gives me the project. So let's see where they are. Okay, maybe there. Yeah. All right, here we are. So let's see what their problem is. Then let's give them a solution, shall we? Hi there. I'm head of data analytics at the city shipping service. Thanks for coming. I'm happy to help. What seems to be the problem? Our package tracking application is receiving lots of streaming data. Managing the data stream with our current resources is getting expensive. Our data analysts need the clickstream data, but I'm concerned about the budget and the amount of resources required to operate effectively. Do you need to pre-process your streaming data and run analytics in real time? Yes, we are aiming for that, but it's not an easy process for us right now. We use Amazon EC2 instances in our backend to pre-process data and run analytics application. Amazon Kinesis Data Analytics is a great way to transform and analyze streaming data in real time. We are forecasting exponential growth. Can this solution handle that? Yes, Kinesis Data Analytics takes care of everything required to run streaming applications, and it scales automatically to match the volume and throughput of your incoming data. Using Kinesis Data Analytics, you have no servers to manage, no minimum fee or setup cost, and you pay only for the resources your streaming applications consume. Well, now I am intrigued. I think this could work. Can you help us manage our data using Amazon Kinesis? Sure, why not? Let's check our rewards. Okay, so they bumped up from 50 to 75 gems, and we are going to learn about Amazon Kinesis. And in season 1, we never did any project on Kinesis. So here is our chance to learn how to implement projects related to Kinesis. So I'm excited. And the objectives are: create an Amazon Kinesis data firehouse delivery stream, configure the clickstream data pre-processing with Lambda, configure clickstream storage into S3 bucket, create an Amazon Kinesis data analytics application. Okay, so there are a lot of things that we are going to do, and I am excited. Let's click accept. Thank you. I'm super excited to see the solution. Wow, everybody's excited. I hope you guys are excited. Here we have our diagram, and look at the video concepts. And the video concepts here we have Kinesis, Lambda, DynamoDB, S3. We even have Glue here and Athena. Okay, and as usual, I'm not going to play these videos here. And if you are interested to learn about this and watch this, you already know where to get them. We already have a playlist on our channel, which is called AWS Tutorials for Beginners. Then go there, watch this in detail, and then come back and watch the rest of the lab. Why you want to do that? Because if you want to obviously follow with the lab, you need to know what each of those services does. And one way, and the best way to do is go watch those videos on our channel, then come back and watch the remaining. Okay, so looks like we have about 10 steps. And the first one, this solution uses Kinesis Data Firehose to ingest, transform, and make real-time data available to Amazon Athena, a petabyte scale query engine. Right, this Athena just queries data on top of S3. Kinesis data fire hose reliably loads streaming data into data lakes, data stores, and analytics services. I think which is showed. You can see here we have Kinesis data fire hose. Clickstream data is coming in, and then it can send data to Lambda function and transform. Then it can send it to Lambda function and then DynamoDB and then S3 buckets. Kinesis is a fully managed service that automatically scales to match the throughput of your data and requires no ongoing administration. In this solution, the source application generates data from the activities on a web page. The data is represented by a sequence of clicks on each website link, which is called clickstream, which is nothing but all the clicks that you do while you are browsing. The data is sent directly to Kinesis data firehose, which runs a custom transformation through an AWS Lambda function before sending the data to its destination. For this solution, the destination is an S3 bucket, as you can see here. After the data is stored in S3, you can use AWS Glue to catalog the data and its schema and continually make updates as new data arrives. The process of discovering new data and schema changes is done by AWS Glue crawler. When the crawler runs, it makes the new data available for the querying by Amazon Athena, because Athena requires schema to query, right? It is SQL. So that schema can be provided by AWS Glue crawler. What it does is it looks at the data, then figures out the data types and column names and etc. And then creates a schema, and Athena can use that schema to query data on S3. Amazon Athena is an interactive query service that you can use to analyze data directly in Amazon S3 by using standard SQL. This solution uses another Lambda function to receive and save the data to Amazon DynamoDB table, which serves as the data source for one or more analytics dashboards applications. So multiple things are going on here. Here, visualization and analysis. Here, you are storing data onto DynamoDB. Then from DynamoDB, others applications can query. Okay, now we have our practice lab goals. Let's see what we are going to do as part of our practice lab. We will create an Amazon Kinesis data fire hose delivery stream. So let's turn it on. So which is something here. This one we'll do. Then we will ingest and store clickstreams data in S3 bucket. Transform ingested data by using Lambda functions. Create real-time queries by using Glue and Athena. So we are going to do all these things. I'm excited. Then the DIY part, which they won't tell us how to do, but we have to do. Then we will edit the data fire hose delivery stream to send real-time analytics to Amazon DynamoDB table. Then we will change the S3 buffer hints, buffer interval setting to 60 seconds. What this buffer hints and buffer interval we will learn as we do our lab. So let's click on practice. And it has a whooping 55. There are no downloadable, but we have about 55 steps to go. So brace yourself, go grab a cup of tea or coffee or whatever you prefer to drink, because it is going to take some time. All right, so first of all, we will go to Kinesis. Amazon Kinesis has 4 main capabilities. One of them, video streams, data firehose, and data analytics. Using Amazon Kinesis data firehose, you can capture, transform, and load data from streaming sources into AWS data stores for near real time. Get that, near real time. It is not real time. Okay, it is near real time analytics through your existing business intelligence tools. Okay, then they are asking us to click on delivery stream. Then the source is direct put, because we are getting data directly from there. We will see what other sources are there. Destination is 3. We will check what other destinations are there. And the stream name we are going to give click stream data. So let me copy that. Kinesis data fire hose delivery stream support 2 input methods. Okay, there you go. They're already talking about it. One of them is direct put and another is Kinesis data streams. The first method can be used to send data from other sources by using Amazon Kinesis API calls directly, as well as from sources such as Amazon CloudWatch logs. In the second method, which is data streams, you can connect a Kinesis data stream directly to a delivery stream. Okay. Click next and then enable data transformation, because we are going to transform data using Lambda function. then maybe I think the Lambda function, they already created it. So they want us to select it by going to browse, and I think we'll pick that. Kinesis Data Firehouse supports record pre-processing through Lambda. Okay, so as you are reading the streams in near real time, you can actually transform it as well. A Lambda function can perform transformation on streaming data before delivering it to destination. For example, let's say if you have 1 million records, but if you think only you want the aggregated, then you can use a Lambda function, transform it, and then aggregate it, and maybe output only maybe 1,000 or so records. Okay, then we'll choose the Lambda function. What is it? Data processing function. Remember it. When creating an AWS Lambda function to perform data transformation, be sure to note that the data sent to your function by Kinesis Data Firehouse is encoded in base64 format. Okay, so sent to your function. So from Firehouse, data sent to function should be encoded in base64. Got it. And then once we browse it, okay, we have to select the destination. Obviously, we will read streaming data using Firehouse, then transform it using Lambda, then store it in S3. So we have to pick a S3 bucket. Firehouse supports AWS and third-party destinations. Some third-party service providers have built-in support for Firehouse. For custom destination, the service can deliver results to HTTP endpoint of your choosing. Then we are going to pick data bucket F6. We'll choose that. By default, Firehouse adds a UTC time prefix before writing objects to S3, creating a hierarchy in the bucket such as that. So under this bucket, I think it will create a folder, this, and then that. And then S3 bucket prefix, we are going to put processed data. So in that bucket, we will create a directory, and under that, we will have all the processed data go into this, and any error output will go into that. Okay, so if data processing fails for any reason, the resulting output can be sent to a separate S3 prefix so that the data can be investigated separately. Okay, I think let's go and open the lab because I don't think I will remember if we go further. First of all, where are we going? Let's search on Firehouse. Create our first delivery stream, and actually there is one more right now. They only explained about data streams and direct put, but there is MSK. Choose this option if you want to use Amazon MSK as the data source for your delivery streams. So let's pick direct put for us. Destination, it's going to be Amazon S3 for us. Delivery stream name is this, and we are going to do transformation. So let's turn that on and browse it. I think it is a data processing function. Oh, I selected it, didn't I? Okay, so let's select this, not click on that. It is opening it. Choose, and let's leave all that. And then let's choose the bucket, and it is going to be this. Choose it. And the prefix they wanted us to have is processed data slash, and then it says error slash. I think that's it. Let's go back. Okay, we are up to date. Then they want us to click on buffer hints, compression and encryption. Buffer size they want 5 MB, buffer interval 300, and then scroll down. Firehouse buffers incoming data before delivering it to the specified destination. The recommended buffer size for the destination varies between service providers. Contact the third-party service provider whose endpoint you have chosen as your data destination for more information about their recommended buffer size. Got it. Click on advanced and choose existing IAM role, and the IAM role we are going to choose is Lab Kinesis Firehouse role. Then click create delivery stream. For Kinesis Data Firehouse to assume and use the specified AWS IAM role, the role must include a trust policy that allows firehouse.amazonaws.com. Cool. All right. Once we create it, Firehouse supports storing data in S3 by using gzip, snappy, zip, or Hadoop compatible snappy data compression as well as uncompressed data. Cool. Now then we'll go to glue. So let's finish this before stepping there. We are done. So let's click on buffer. I think default we can leave it. The higher buffer size may be lower in cost with higher latency, right? Buffer means you are going to store data until it reaches 5 MB. So you won't write it to the target until you reach this, which means the more late the data is going to be in the destination. So it depends on how far do you want it to be fast, or do you want it to be like more, right? You want to accumulate data before writing it to that. So the buffer size decides that, or you can even have the buffer interval as well. Did we pick any compression? I don't remember. So let me go back quickly, check it. Yeah, they didn't show us anything. Okay, so let's come back here and advanced settings. Okay, where is role? Okay, here, choose existing IAM role. Click here, that, create the delivery stream. All right, here we are. Let it get created. Let's go to glue. What is glue? It is a serverless data integration service that helps you discover, prepare, move, and integrate data from multiple sources for analytics, machine learning, and application development. Think it as a ETL tool, a serverless ETL tool on AWS. So once we click on glue, let's go to databases, not ETL jobs. Usually you do that, but here we are using glue not for creating ETL jobs, instead to crawl data and create schema. So in order to do that, we need to go into data catalog, and in that databases, we will add a database where we want the schema to be created. Glue data catalog is a central repository to store structural and operational metadata for all your data assets. For a given data set, you can store its table definition, which is schema, and physical location, and business relevant attributes, which are columns, and track how this data has changed over time. So let's create a database and let's name it Firehose Inbound, and then create the database. After you add your table definitions to the data catalog, the tables are available for ETL and also readily available for querying in Amazon Athena, Amazon EMR, and Amazon Redshift Spectrum, so that you can have a common view of your data between these services. So this is like a central repository of your schema, which you can use in other services as well, and we are going to use Athena. Next, you can use a crawler to populate the data catalog with tables, right? That's the point of us even creating the database. Under it, we are going to add table using crawler. Crawler is just, it goes through the incoming data and checks all the data type and etc. You will see it. And the what are we seeing here? A crawler can crawl multiple data stores in a single run. Okay, it doesn't have to be one at a time, and we are naming it that. So let's go back to here, and I think it is available active status, which is good. So let me go here, instead of functions, glue. Okay, and we are going to go to data catalog, databases, add database, name it this, create. Okay, let's click on that, then add tables using crawler, not table, because we are going to use crawler. So we will click this one, and the name they want us to give is this one. Then once in the second step, we have to pick data source configuration. And is your data already mapped to glue tables? It is not. We are going to do it the first time, so not yet. And then we'll add a source. You can choose to crawl a path in your account or in another account. It doesn't have to be in your account. Then what is the data source for us? It is going to be S3. And then in this account or different account, then we'll browse S3. If all the S3 files in a folder have the same schema, the crawler creates one table. If it has different schema, different files, then different tables. Okay, so we are picking the bucket, then choose, and then we'll pick process data. Remember, not the entire bucket. And we are telling it crawl all subfolders. Okay, because I think process data, I think it is going to have year, month, and etc. So it will crawl everything. And then we'll add this data source. Good. And then click next. And then we have to create a new IAM role, or if there is already one, we can pick it. The role you pass to the crawler must have permission to access S3 paths and DynamoDB tables that are crawled. Got it. And I think we don't have DynamoDB. I don't know why we need access, but in case if you are crawling on DynamoDB tables, I guess that's what they're talking about. And the name they're giving is data ingestion. They just added to that. That's fine. Create it. Fantastic. Scroll down. And then the target database is what we are crawling. We gave the name to the crawler, etc. And the table names it will automatically create after crawling it. But the target database, where do you want the database that we just created, which is Firehose inbound. And then we are giving frequency, how often you want it to crawl, and minute of the hours, */5 means every 5 minutes, I am assuming. And the start hour, you are not giving like all, day of month, all. When you create a crawler based on a schedule, you can specify certain constraints such as the frequency the crawler runs, which days of the week it runs, and at what time. These constraints are based on cron. And then we'll create the crawler. Awesome. Okay, now let's go back and let's try to do the same thing. Okay, that is the name. Click next. Not yet. Add data source S3 in this account and browse bucket. This bucket, open it, because we have we didn't yet start it, right? Okay, never mind. So pick that, choose it, but have this processed data. We don't have the directory yet, but that's what we are going to use. Add data source. Next. They don't have it, so let's create an IAM role, and the name we should, what did they give? They gave data ingestion or something like that. Okay, it's created. Okay, IAM role is required. Yes, I just picked one. And what else? I think that's it. Next, target database is this. Table name prefix, it's optional if you want, but it is going to again create it automatically. Crawler schedule, let's pick on demand. Is it like, do we pick it here? Yeah, I think we pick it there. So previous on, it's not on demand, it is, let's pick that, not monthly, custom. And what did they put this? */5. */5. I think that is means every 5 minutes. All right, next, create crawler. We successfully created our first crawler. Good, let it be there. Next, now we are going to go to our EC2. The put record batch API method supports up to 500 records, each of which can be up to 1000 KB in size. So what are we doing? We have to generate the data, clickstream data, right? I think that's what they might be doing here using the web UI or the IP address. So we will open this. So the web UI website will open, then we'll do some clicks, I guess, that will be recorded, which will be sent to Kinesis Firehose, and then final Firehose will transform the data using Lambda, then it will store in S3, and then Glue crawler will crawl through those files, and then it will create the tables and the schema. Wow. Up to 4 MB for the entire request. Okay, so they want us to go there, copy IP, then /Firehose, then Amazon, they want us to give our stream name so that it will write to it. Okay, nice. So let me click on that, copy it. Okay, now if we come here, EC2 hosts an application that generates sample clickstream data, as I mentioned, and sends it to the Firehose delivery stream. The encoded data is in a .csv file format. All right, next, start test data stream, start. Okay, by default, each delivery stream can intake up to 2000 transactions per second, 5000 records per second, and 5 MB per second. You can increase this limit by submitting a service limit increase request. Okay, so let's click on start on that. And once you do that, what are they asking us to do? They want us to go and check the data processing function to see what it is doing exactly. I'm assuming code. So they want us to look at the code, which we will do. Scroll, review, code. And then as you can see, if you come to DynamoDB tables, or they already have a table created. I thought this was glue database, data catalog database, but it is not. This is the DynamoDB table, output table. I think this is where we will write our data to. Scroll down. DynamoDB, we already know, is a fully managed serverless key value NoSQL database designed to run high performance applications at any scale. And then what are they telling? Okay, I think it is some, by the time we started clickstream data, I think they want to check if the data is coming in. Data streams uses the concept of shards to manage the throughput of a single stream. Kinesis data Firehose automatically scales based on the demand. So they are telling difference between data streams and Firehose. Okay, so data streams uses shards to manage the throughput, whereas Firehose, it will scale automatically on demand. You don't have to manage it. Process data, I hope the data is coming in there. Yes, they have it. By default, Firehose appends the prefix, the timestamp, to the data set it delivers to S3. You can override this default by specifying a custom prefix that includes expressions that are evaluated at runtime. Okay, that's how the data looks like. Then the crawler runs. Scroll down. So here we are. Where are we? Athena. Okay, why are we in Athena? Because once the crawler creates the tables, we want to use Athena to query. So we are here in Athena. So before we go any further, let's go ahead and do what we are supposed to do. What are we supposed to do? We are supposed to generate some random data. So how did we do that? Let's go to, let's see here. Do we come back here? I don't think we'll come back here. So let me open EC2. Instances, web UI, copy the public. Let's open. So we need to add the Firehose. Okay, here we are. And what was the name? Oh man. Was it clickstream data? Is it all small? I don't remember. So let me go here. Firehose. It is this. Submit. Start. Test data set is that. Let's start it. Okay, that is dataset 1. Did they ask us to do dataset 1 or everything? Press each button below to send data. Oh, okay. I don't know why they can't do it automatically. Why do I have to click it? Okay, that's fine. Okay, how many we have? 4. All right, so there we go. We did it successfully. Now let's go to S3 to see if the data is coming. We did give 5 MB, so it might take some time, I guess. Yeah, so let's give it a minute. Okay, in the meantime, what we can do is we can go to the DynamoDB and check out the table that was created there. And if we click on tables, we already have the output table. Got it? And explore table items. There is nothing in it, no items, nothing else. I am assuming the lambda that we use might be creating it. So let's check the lambda as well. They wanted us to anyways. Here we are. Let's click on the data processing function, because this is a function that is going to process the data. And looks like this clearly says manage, I think, because we are using this in Firehose. Okay, they wanted us to look at the function, and here, as you know, the handler is the function that actually processes everything as part of the lambda function. So this is the one that gets triggered when you run the lambda function. And these all are commented. They are just showing you how the delivery stream record looks like. We already know how it looks like because when we are testing the data, we saw it there. And they have a response, which is the output or whatever the lambda function returns. So they have different labels, previous, current, type, etc. And then they are iterating through these input records, and then they are converting it to base 64. Remember, when you are sending data from Firehose to Lambda, that said you have to convert it into base 64, which is what they are doing. And then they are splitting the lines based on the end of line character. Then they are looping through lines, and then they are appending different columns. They are splitting by tab. Looks like the data is tab delimited. So they are splitting into different columns, and then they are appending it to the records. Then they are preparing a data frame, which is a table, and then they are sending the data. So basically it's a pretty simple function. They are not doing much. They are just processing the data. So I am assuming, okay, they are converting it into a CSV at the end. Header false, which means there won't be any column information in the file. So let's go back. It's been a while. Let me click here, exiting. Okay, here we go. So if I refresh, I think I should see a bunch of files. So process data, year, month, day, and then I think hour. Based in the hours, you can see, right? We have a bunch of files. So let me download a file, or let me just click here. And I don't know if it will let me open in the SQL this the result. Let's see. I did. So as you can see, the data, we divided it into, even though the input data is so much, we don't want all the junk information. So they read the record, split it into 4 columns, and then they delimited it with comma. And here you go, CSV, right? So comma delimited, you can see, which is nice. So that's how the data looks. We are getting the data. Cool. Once we had the data, they wanted us to go to the glue, right? Okay, let me go to glue, and then crawlers, and this is ready. But did it run? Yeah, last runtime it ran, so we are good. Now let's go to Athena. Let's connect to this particular table from the database we created. So let's click on Trino SQL using PySpark. I think this is fine. So it already picked it. Data source is that, and the database is that, and the tables, they already created it, processed data, and they created it, and they created the columns, as you can see here. So let me go back. So I think that's where we are. So it created it. And Athena is a serverless interactive analytics service built on open source frameworks supporting open table and file formats. Athena provides a streamlined, flexible way to analyze petabytes of data where it lives, which is in S3. So we will click on the settings, query editor, settings, manage. You can use Athena to analyze data or build applications from S3 data lake and 30 other data sources, including on-premise data sources or other cloud systems using SQL or Python. And then what are we doing? Okay, so once you query a result on Athena, you need to store it somewhere. So before you can run a query, it will ask you to pick a bucket and then a folder where you want to store those results to. Okay, that's what it is. Before you can run queries in Athena, you need to configure S3 bucket location to store query data. Cool. Okay, I think that is the bucket. I think it's the same bucket. I think it will create folders automatically. So we are good. So let's go back. I think, where is it? Okay, I think it is here. and it wants us to go to settings. Oh, not here. Okay, let's see. I think it will by default ask if I click run. No. Oh, this is DynamoDB. Never mind. Okay, here we go. Okay, if I click on edit settings, yeah, here is the bucket. Click browse. We only have one. Choose it. I think this we don't have to. So let's click save. Okay, now we have the bucket. So let's click on the process data, then these three dots, vertical dots, then preview table. Then it will automatically paste the select, review it, run again, then scroll. We will see the data. As you can see, columns, column 0, column 1, and the data. Scroll, 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 and you can see the partitions it created. It created partitions based on the timestamp. Glue crawlers automatically identify partitions in your S3 data. And then finally, we are writing our own query here. Do they have it here? I can copy paste it. Yeah, it is there. Okay, let me copy that. Okay, what is the concept here? Athena supports a subset of data definition language DDL and manipulation statements, functions, operator data types with some exceptions. Athena DDL is based on HiveQL DDL. Okay, then once we copy paste it there, run again, then you will see aggregated data. And oh, they want us to start this now. I started it a while ago. Multiple streams might come into Firehose. Streaming data is data that is generated continually by thousands of data sources, which typically send in the data record simultaneously in small sizes. And I already clicked it. Okay, that's about it. So let's go and finish this. Let's go to query editor, and initially they told us to go to tables. Click on these three vertical preview table, so it will automatically, and it also running it for us, which is nice. As you can see, we have 4 columns and the partitions as well, which is good. Now let's go ahead and paste our query and let's run it again. Now this gives you aggregated data because you're grouping by and column 2. So now you see count, we have more than whatever they are showed because they only ran one data set, whereas we ran all 4 data sets. Success. So that's about it about the practice lab. And congratulations to me and congratulations to you as well because you watched it. So you, I would say, got 50% of it. Why not 100? Because you didn't do hands-on. Doing hands-on is completely different than watching somebody else do it. Okay, that being said, what did we learn in here? We learned how to create Firehose streams, which we created. Then we also configured it to transform the data using a Lambda function, and we picked the source as direct put and then the destination as S3, and we created, no, we didn't create it, the S3 bucket already existed, and we created 2 prefixes in it. One is process data, another one is error in case if there are any errors while streaming the data. And then we didn't do much about the DynamoDB because we didn't write the data to DynamoDB at all. It is there. I am assuming as part of the DIY we'll do it. One important thing we learned is about AWS Glue data catalog and crawler and how it crawls the data that is stored in S3, etc. Then we learned about how to query using Athena. Okay, so a lot of things. We learned a lot of things. I love it. Let's go to the DIY and let's finish it, and then I will be proud of myself. Okay, now they want us to edit the stream to send real-time analytics to DynamoDB table. Okay, right now what is happening? We are sending it to S3. Now they want us to send it to DynamoDB. Okay, then they want us to change the buffer hints. Previously we used the default buffers, which is I think 300 seconds. Now they want us to change to 60, and then they are giving us how they will validate DynamoDB table name. Okay, let's go back and see. I don't know. Let's see how to do it. I'm not sure. Okay, we have the stream already here. Let's go ahead and open it, not delete it. Let's do close. How to edit it? configuration. Okay, we can change this, but what do I want to do? Yeah, here we go. Edit this. This is just 60 seconds. What do they want us to put? Yeah, it is 60 seconds. That's weird. Okay, let's cancel this. Scroll down, edit this destination, and destination settings. Okay, no, I think maybe it is not here. Configuration, transform and source records. Oh, I think it is this. This is the one they want us to modify. Backup settings, server service. No, what I'm looking for is how do I even edit that setting? Do I have to delete and recreate one? But they said edit it. Okay, so here we have the Lambda. Cancel, which is not what I'm looking for. And by default, this is picking S3 destination setting, buffer hints. This they want 60. Save. Okay, let me go read it. Edit the Kinesis delivery stream to send real-time analytics to DynamoDB table. Okay, let me quickly do something. What I want to do is look at here. Okay, so there is a Lambda function that does it, and that function loads the data into that. Good. Okay, how do we do this? What is the Lambda function? Did they give us a name? So let's go here. Let's go to functions. Lambda monitoring. I think it is this analytics destination function. I think this writes to DynamoDB. So they want us to look at this and learn on our own. Is that it? Yeah, it is putting in the DynamoDB. I think okay. So there is environment variable. So if I go here, okay, not here. Configuration, environment variables. Oh, it's already named output. So it is already configured. So all we have to do is point this table to Kinesis data streams. I think we should be good to go, right? Is that it? Or let's see. No, it won't get it from there. We have that. We have this response for recording events records. Try this. Okay, hold on a minute. I think it's the same. Yeah, we will just pass it to we'll just pass it to Lambda, this particular function. So not Lambda, Firefox. So let's go there, Kinesis, and then we have transform and convert records. What if I edit this? No, I should be able to data streams. No, not data streams. I want to have data Firefox itself. Okay, what I will do is let this be there. Okay, if I create a new delivery stream, what will happen? We won't get any data. So we need to edit this. And configurations, edit. Let's edit this Lambda function. Let's browse it. Let's pick the analytics destination function. Okay. Oh, I'm not supposed to do that. So let's go to, okay, here, select that, choose, save changes. Previously when we checked, there were no, what do you call it? There was no data in the DynamoDB. So let's see if this is going to write to it. I mean, we can delete this completely and then create a new one, but I'm just stuck here. Edit, they are talking about editing it. Let's see, where is this? This is still sending data. That is good. Okay, here we are, DynamoDB. Previously we didn't have any data. Okay, I think it will take some time. Let's give it some time. It's not even been 1 minute, and as you can see, the data started flowing into our DynamoDB table. I think that's the trick, guys. All I have to do is modify that Lambda function to the Lambda function where it is writing to the DynamoDB table. Okay, and this is our table name, and that's what they are asking for. So let's give it here, validate. This should be successful. Green, green, green. Yes. Now to the city and all right. So I think it's not that hard. It's just I have to swap that other Lambda function with this Lambda function where it is writing to DynamoDB table. That's cool. So we have learned a lot of useful stuff in here. We didn't learn, too deep into each of these services, but what did we learn? What is the awesome thing that we learned? We learned about how these different services connect to each other, how Firehouse connects to S3, how you can use Lambda to transform data while you are streaming the data, and how to write DynamoDB table using Lambda, the streaming data, and how to use Glue crawler, Athena, etc. So it was amazing. At least that part I liked it. The part where they showed how to integrate all these tools, because this is a solutions architect role, right? Not a developer. So I think whatever they showed works for me. Thank you for this solution. Choose a reward. What do you want? I think the stadium is fine. It's fun. Okay, fireworks, which means, hey, look at the giraffe. And I think there is something here as well. Leveled up, builder leveled up, and it's feedbacks time, and congratulations, data ingestion methods delivered, and give feedback. And it's time for you guys to give me feedback. If you haven't already subscribed to this channel, go ahead and do so. It will really help the channel a lot. And not just that, you don't want to miss the amazing content we are putting on this channel, right? You can go ahead and check different playlists. We have a diverse set of playlists, and even if you are not interested in others, just this playlist you can use, right? The Cloud Quest, it is not just a video game. You can use whatever the projects we are showing here. You can use them in your resume. You can even use them while you are having an interview. You can tell them you perform these projects because you know how to do them. That's all matters, right? And if you are already working somewhere, obviously you can look, watch these projects and implement them at your work. So that is the second use case. Third, you can clear certifications very easily after watching this because you clearly know what you are doing. If you are a student who just passed out, you don't have the 6 months experience that AWS mentions, like, oh, in order to write these certifications, at least we are expecting you had this level of. By looking at this, you will get that experience automatically, because what is the difference between a person who is actually doing them at work and this? It is the same. Got it? So there are so many useful things that come from watching these videos. So go ahead, do that. So in order to do that, subscribe, and don't forget to hit the bell. Why? Because you don't want to come and check if I uploaded a new video every hour. Instead of that, click on the bell. What will it do? It will send you a notification as soon as I upload a video, right? Easy peasy. You don't have to keep checking here. And if you want, these awesome videos in this series posted every day or every other day, all you have to do is hit the like and comment saying if you are loving the videos or not. At least, even if you don't want to comment, just hit a like. That will tell me that people are interested and they want me to post these videos every day or every other day. All right, that's all you have to do. Okay, so that's enough about the channel advertisement. Now what are we going to do? We are going to zap some drones. Again, I didn't watch the videos, so I might do a couple of answers wrong, so just bear with me. Okay, so the best way to do these drones is after watching those videos, because that's where the content comes from. Okay, if I'm not sure, I will just use the hint. Built-in data conversion formats does Kinesis Firehouse support? There are about 2. I know it supports, I think it should support this. Apache Hadoop, I don't think that is a thing. I think it is Arc and Parquet. Let's click hint just to confirm. Okay, I'm not cheating here. Okay, let's see. Let's search on Parquet. It will automatically give it. Yeah, Parquet or Oxy. I said I'm not cheating. Not bad. Not bad. It's a good start. Okay, where are you going? Stop. Which AWS service can streaming data be loaded into using Firehouse? We definitely know S3. There are three. Okay, we didn't see the targets. We just checked S3 and we ignored these. How about, I think we can do it for OpenSearch, but I'm just contemplating between Redshift and RDS. I think maybe this, because pretty much these three are like Amazon services, even this, but the database differs. So let me click on hint. OpenSearch. Okay, here we go. So S3, Redshift, OpenSearch, Splunk. Yes, I'm on a roll. Yes, we got an availability zone. And are you blue? Okay, let's zap that. In Amazon Kinesis data streams, only one application can consume data from stream at any one time. I would say false. I think data streams you can have multiple applications you can consume. I'm assuming. Let's click on this just to confirm. Although you can use to solve a variety of streaming data problems, a common use in developed by loading the aggregate data into data is put into which ensure durability. The data between a time and is put into, and it in other words, application can start consuming the data from the stream almost immediately. Okay, multiple data stream applications can consume. I think that's good enough. So the answer is false. Yes, I'm on roll. Okay, why are you this low? Hold on. Yes, it's a high. I hit. Okay, which method is used to publish data to Kinesis video stream? See this is what I'm talking about. We didn't use Kinesis video stream in our labs. So how would you answer this? By watching those videos. So let's do some guessing here. Which method is used to put data to video stream? So it's a video stream. So upload the video button on the, no, use the latest version, CDK, use the put media API operation. I would go with S3 because it's talking about video stream. Upload a video directly to S3 which publish data to. I would go with either these two. So let me click on the hint. Okay, so here we have, you can publish media data to via put media operation. So I think whatever I picked is the right one. So let's click answer. Yes, wow. Today even my guesses are working for some reason. So any more near me? That is too far away. Okay, we have one here. I mean, unlike yesterday where we had only one question, today they are giving multiple questions on this. Let's see how long we can do these Kinesis questions. Which compression formats does Kinesis? Okay, I think Snappy, Zip, Zip. I don't think 7-zip is. I'm assuming yes. Wow, today looks like my lucky day. Okay, let's go ahead. Let's see if this is our last question. Which resource helps to securely stream? Okay, I mean, we are doing Kinesis, so it is either this Lambda streaming analytics. We know, I think it is this. Clearly we are doing Kinesis questions, so even if I don't know the answer, I can just answer it. Kneel before me. Which compression formats does? Okay, it is repeating now. I think it is good to say that we are out of questions, so we can stop zapping the blue ones. Let's try to do a orange one. Let's see if I have one nearby. Okay, here we go. Okay, let's finish this. And they are talking about EC2. I don't know if we have. Let's see. I think we might have EC2s, EC2 cards. Okay, looks like we do have it. Nice. The sales team wants the exact same configuration in all its EC2 servers. Help the team create a server template that will ensure all created instances are identical. Sure, why not? What do we need? We need we need auto scaling, and then we will create, what do we create? I think machine AMI. We have to first create an AMI, and then we will use that AMI to create different machines using auto scaling. It's as easy as that. That's it. Collect, and let's see if we can do one more. I don't know, today I'm feeling lucky, so maybe we will get another architectural question where we have the cards. And here they are talking about delivery kinesis. I'm not sure if I have. Let's check it. Okay, we don't have Lambda function, so let's exit. I think that's all for today, viewers. I hope you enjoyed with this video. If you did, then go ahead and hit the like button and even comment, if you want to share something with the other viewers. Okay, thank you very much for watching this. At least I learned a lot of things, new things from here. So if you did, then go ahead and hit the like and comment. If you haven't subscribed, go ahead and subscribe to this channel. Thank you very much. And we have 6 more projects to go as a solutions architect. And after that, I'm thinking of starting data analytics. So thank you for your support. See you in the next one. Have a great day. Peace out.